this problem, maximum subarray, given an integer array nums, find the subarray with the largest sum, return the sum. So we are given nums, which is this array over here, minus 2 1 minus 3 4 minus 1 2 1 minus 5 4, and we have to give the maximum subarray sum. Here the answer is 6. We have to return 6, and that's because 4 minus 1 2 1, the summation gives us 6 as the answer. For nums like 1 to be present, we'll give 1. For 5 minus 1, for 5 4 minus 1 7 8, the answer should be 23. That's just the sum of all these numbers. The nums length is between 1 and 10 power 5, and individual values is minus 10 power 4 and 10 power 4. So the intuition here is that we can for all I where I is index values, right? So we can either start a new subarray from that I, right? Or like that is one thing that we can do, or continue an existing subarray. So the point is that we can define max subarray sum to be minus infinity, because we'll keep taking max values. So minus infinity is just a good number to compare with if you want the maximum value. And we can have current subarray sum. Right. So now the idea over here will be that that we can loop for I in range length nums, right? What we can just do is current subarray sum can be maximum value of nums I plus right. So essentially, like let's say like let's take this example, okay, that we have minus 2, so we can update this value initially can be, or we can just put minus nums I over here. Okay, so now let's go over this. So we have, let me paste this over here. Okay, so we have this value now, right? So we have initially we have the value of minus infinity, right? So after that we will update this to be equal to, so this will be minus infinity minus 2 or minus 2. So the answer will be minus 2 over here, right? This is the first example. If we take the second example also, this will be minus 2 plus 1 or 1. So the point here is just that we can take 1 itself, right? Like why even we don't need to have this value anyway of minus 2 and 1. We can just begin that subarray at 1 and then we can continue with that. So, and the thing is the same thing over here, that if we take 1 minus 3 and minus 3, we should take 1 minus, we should take minus 2 because like negative minus 3 is smaller. So essentially, like the subarray that we'll consider is starting at 1 going at minus 3 and then 4, right? But then when we go to 4, we can just consider the subarray as is, because the sum will be 2 and that number itself is 4. So we can have we can start a new subarray here after 4, right? And then we'll have we'll have 4 minus 1 or minus 1, and that value will be 3, so we'll take 3. Similarly, we'll have 2 or 5, right? We'll take 5, and then we'll have 1 or 6, so we'll take 6, and this 6 will be the answer that we want to give, right? Now after that it'll be 6, like 1 or minus 5, and then 1 or minus 5, and then basically we'll give 1, and then we'll have 4 or 5, and then we'll just give 5. So yeah, this is the like, let's try to implement this. So we'll have max subarray sum is equal to minus infinity, and then we'll have current subarray sum, and this will also be equal to minus infinity, right? And then for num in range, for num in nums, right, we'll have current subarray sum, right? This can be maximum value of current subarray sum plus num, or num itself, right? And then similarly, max subarray sum can be the maximum value between max subarray sum and current subarray sum. Like whatever, if we update, we will always want to keep an updated value over here, and then we can return max subarray sum. So let's try to run this, and yeah, it's running fine. Now another like aspect of this question is that how, like, if we were to return, if we were asked to return the maximum subarray, right? Like, this is something which I would like to focus on now as a part 2 or like a follow-up of this question, that so yeah, to like give an insight, the time complexity over here is the time complexity is O of n, and the space complexity is O of 1, because we are just maintaining constant variables. Follow-up can be return the max, return the maximum subarray, right? So for this one, like, the approach that comes to mind is that we can typically try to print, like if we have this guy, we can try to maintain an auxiliary array, right? And we can try to have the maximum sum. So here the answer will be minus 2. Here it will be here it will be 1 itself, because we'll take the number. Then here it will be minus 2. Here it will be 4. Here it will be minus. Here it will be actually 3 plus 3. Then it will be 5, then 6, and then 1, and then 5. So basically what we need to do is we need to traverse this array, right? Whatever the max array sum, max array sum. So let's call this max subarray sum. Cumulative or something, right? So this guy we need to traverse from end till traverse backward from end till we find the max value, max array sum value, right? So here we'll start traversing from 5. Is that the max value? No. We'll go on up till 6, right? After that, as soon as we reach that, and then we can just return array. We can just define a return array to be this guy, right? After that, what we need to do is we can just keep we can add that value, whatever value is present in nums, to this guy, right? So nums will be equal to this guy, so we can add nums. So this value is in fact 1, right? So we can add 1 to return array. After adding 1, so basically we will keep traversing back till nums I is equal to cube I, right? So maximum sub array sum cumulative equal to I, because when we do this we know for sure that that is the point where that this array is actually this subarray would have actually started. So we can do this way. So basically we'll add 1, right? So like what we'll have finally is this guy, that we'll have 1, 2, and then minus 1, and then 4, right? At 4 you can see that this 4 and then this 4 is the same. So after that we can just break. So basically when we return, we can return the reversed version of return array, right? So because essentially we are traversing back, so we are adding these guys in the opposite order. So this would be 4, minus 1, 2, and 1. So yeah, I hope you had some understanding.